Hey yo, this is the second part of the GGPO tutorial, and today I'm going to be showing you how to structure your code to make it work with Godot, and I'm going to go through the code and analyze it so you can understand it better. So if you haven't already, go to the Godot module, and then this you need to build this module, and I did that in the first tutorial, so if you haven't done that already, just go through these instructions, or you can go through the first video and I should be able to guide you through it. So once you've done that, make sure to go back here, go to the source files, and you want to download this whole repo. So go back here and then download it. Once you download it, you can get the zip, and this should be the zip right here. I'm gonna pull that up here. No, this is the tutorial. That's something else. This is the zip. So what you want to do is come to GGPO right here, get in the source files, and then get this right here. And make sure these are already extracted. I'll put them on the desktop. And what you want to do is go back to where you compiled Godot and go open it there. So I compiled it under this here, and then go back to your modules, and you're gonna see Godot GGPO, and then delete these two folders, and then or those two files, and replace them with the two extracted files, and then come here and then copy in there. And these are the same, so I don't want to overwrite it. So, but you have to delete yours and add it in there. So I'm going to delete these. And once you do that, you need to recompile this module. But the good news is that you don't have to recompile the whole engine because that takes forever. All you need to do is recompile that module. So what you're going to do is you're going to go open command prompt again. And once you open command prompt, navigate to the Godot folder. So cd Godot 3.2 is where I am, and you can just use sans platform equals Windows, I believe, and then click enter. Basically, use the same command that you used to compile it the first time, and this should rebuild the module, and you wait. And once again, it's going to be much quicker the second time you do this. It usually takes usually 7 to 9 minutes, so it's a bit it's a bit faster. Oh, since I didn't do any edits, it's gonna go way faster. But if you did do edits, um, it will usually take 7 to 9 minutes. So once you do that, you can click exit out. And this would probably be the only time you're gonna be looking in these folders or files for a while. So you can leave these for now. And once you're done with that, go to GGPO where you installed it. And I have mine in the bin. Let me pull it up here. So go to the bin, open this over here, and wait for that to open. And make sure you extract the files for where you install GGPO, the tutorial. And here, you want to go here, just extract that to the desktop. I already did that, so you don't have to. And to find the project, you have to click scan or import. And once you do that, it should show up here, and then you can click into it. We wait for that to load. Did I not click it? There you go. Okay, and it should be working. Why is this freaking out? Okay, I fixed that error. But yeah, this should be working now. So I'm going to go through the process and go through the code. And to be sure that your this file is working, you can just click play and we'll wait. Once it's playing, you should see a block and a number or word above its head doing nothing. And that's because no one has connected yet. We'll do that later. But if you see this, that means the project is working fine. And it might be a little bit laggy because if you look in the background, you can kind of see a bunch of checksums being checked. And I'll talk about that later. So I'm going to be talking about the structure of the code. Okay, so now it's time to explain the structure of the GGPO code that I did. My structure is extremely basic, but it should give you a good foundation. So when you go to your project, you should be able to build off it and make it better. So here we have probably a basic structure that most game engine uses. I know this is really basic, but this is probably what goes under the hood in simple terms. You process your input, so any input from a controller or keyboard or anything you use to capture input, that input gets sent to the game state where it's updated. So if you press like spacebar to jump, all the physics and math is used to calculate where your character is going to go after you hit the jump button. And then those physics and math and all that stuff is rendered to the screen so you can see your character jumping. And just say if your game is in 60 frames per second, this will happen every 16 milliseconds. Okay, so if you now go to GGPO, it kind of uses this structure, but a little bit differently. So let me pull it up. So this right here is kind of how GGPO works. So you um you take your input like before, and that's sent to update game. But if say, you know, you get out of sync, GGPO will run the update frame many times per second until it's back to sync, and then you render the frame. You don't want to render the frame and run this many times per second because that would take way too long to do because rendering frames takes, I guess, a lot of power, and it would be much slower because this update function is running a lot of times. I don't know how many times, but I know it's a bunch. So this is a basic GGPO diagram, and I made my own diagram, but this one is more in depth, and it's basically how I coded the project. And you don't have to worry, this diagram is also in the GGPO tutorial repo, so you can look at it. So I'm going to go through all of this, and then I'm going to match it up with the code, and you should be able to follow along and see this. And once you understand this, it might look complicated, but it's actually extremely simple. So let me get into it. So first of all, I'm going to go through it real quick without the code, and then I'm going to go to the code and then go over it a little bit more in depth. So let's say let's let's start. Okay, so you start the game obviously. Um, then you set the frame delay, and I know you might be saying, "Oh, I thought we're not using a delay-based netcode." Well, you still use a delay, but it's really not noticeable. It's only like usually 2 frames or 3. So it still uses delay-based netcode, but it's not noticeable. And you can change it. You can add players. Obviously, you need to add the players to play the game, and then you start the session. So you get your local input, and then you come down here, and then you synchronize input, and that's just getting your opponent's input and your input, and you synchronize it to the game state, and you send it to the game state. Okay, so I know I've used the word game state, and some of you might be confused to what that is, and I'll explain it real quick. It's actually pretty simple. So if you've ever made a project where you had to save a game, you might have used what is called a save state. And what a save state is basically it saves all the information needed to reference when you boot up the game again. And let me pull up an example that Godot made. So you can see this save state basically has the position, the attack, basically attack power, the defense, max health, basically has all the stats needed. So when you open the game again, um, you would have all this information and nothing's changed. So what a game state is basically a save state, but instead of updating or saving every time you close the game or hit that save button, it now this happens or these properties get updated every frame. So once you move your character right, that gets updated to the game state, and then the game state gets passed to the update function. Update function gets passed to the render thing, and then it goes through a loop again. So it's basically this picture that I showed you before, but when you click input process, that gets passed into the game state, and that's somewhere in the middle. So that's what the game state is. So in simple terms, the game state is basically the state of your game or the current position that your game is in. So I just have to get that out of the way. And for GGPO, you have to have your game state as optimized as possible. And I'll explain why in a second. So let me continue. Okay, so you have synchronized input, and I'm gonna show a picture on the screen, and I talked about this in the first video, but it basically shows the opponent's input and then your input, and I think it says local input, and then they meet together, and the synchronized input is where that happens. That gets passed to the update function, and you can see the update function gets called by two functions here, and I'm going to talk about advanced frame later, but I'm just going to go through the simple motions. Synchronized input goes to update. Is the game synced? I'm going to say yes for now. Let me get called by advanced frame. And not to get mixed by these two, this advanced frame right here basically lets GGPO know when the frame ends. So once it ends, GGPO knows to save the game state, and then it passes it into a buffer. And then this continues, and then you render the graphics. So let me go through here. So we have advanced frame down here, and this advanced frame is called when GGPO realizes that it's no longer in sync. So if you remember correctly, GGPO, once it doesn't get the input, it predicts the next frame by using the previous inputs. And if GGPO realizes that those inputs were wrong, advanced frame gets called. So let's go through it. So advanced frame gets called, and then you go into the update function. The update function will check if it's synced. If it's synced, no, because advanced frame is being called. You go to load the game state, and the load the game state, we go to the buffer and get that saved game state. There, and that save game state is the last correct known frame that Godot knows. So it would go in here, get that last frame that Godot knows was correct, and it will load the frame, and then it will get the correct input from your opponent, and then it will update the game state. And then this will loop again. Is it synced? No. And actually, this it won't go here. I need to change this actually because this is wrong. Let me I'll be right back. Let me fix this. Okay, I'm back and this should be correct now. So you would see that I added an arrow from synchronize input to advanced frame and I flipped the arrow from update to synchronize input. So I'm gonna explain why I did that, but basically, I thought the loop was happening here, but I'm dumb. But the loop happens down here. So let me get back to what I was explaining before. So load game state, once Godot knows that it's behind or it's unsynced, it calls load game state. And then load game state goes to the buffer and gets the last known correct frame. And once it does that, that frame gets called to synchronize input and it gets the correct inputs from the opponent. And then that gets passed into advanced frame. And then those inputs get passed to update. And then this keeps looping around and around until the game is synced. And once the game's synced, it goes back to advanced frame. Advanced frame once again lets GGPO knows that the frame's over. So once again, you save your game state in here, and then you render the graphics. So basically, it's like, yo, once GGPO knows that it's no longer in sync, GGPO is like, yo, those inputs that we predicted are all wrong. So let me go back in the past. Let me get the correct game state. Let me load it, which is right here, and let me get the opponent's input and the inputs that I put, and then let me synchronize it, and then let me update, do the calculations. Okay, he clicked A couple seconds ago, so let me start the jump frame. Go here, okay, he's still holding on to A, so let me put him higher. And he keeps going. And once it's done updating, it's like, okay, so this guy is about halfway into the air, so that seems correct. And let me go render the graphics, and then your guy teleports to the air, and you're confused. So that's how that happens, and I think that should make a little bit more sense. So yeah, that's basically how it works. So let me get into the code and see how I coded it. Okay, so let's get right into the code. So I believe if you were able to understand the diagrams that I just went over, that the code should be just as easy. So I'm going to try going through this faster than I did with the diagram. So we have all our information up here, the port and the player handle. If you don't know what a port is or IP address, I recommend you go look that up because that's very important to this. So go look that up, then come back. So but if you do, let's just get into it. So we have our player handle, and that's basically if you're player one or player two, you have your opponent's port, and then you have your opponent's player handle, and our opponent is player two. We have the max players that can be in the game, set to two. You have your IP address, which is the loopback address, and then you have your player, the number of players that can play in the game, and I set that to two. And then we have the sync test. So if you don't know what a sync test is it's basically allows you to check if you're rolling back correctly. So basically what GGPO will do is it run one rollback frame, since we set it at one, for every frame that goes by. So it's going to be constantly rolling back, and I'm going to show something on the screen of me rolling back or using the sync test, but it basically allows you to check if you're rolling back correctly since you are rolling back physics and that can get messy. But since we're not doing that, we're going to set that to false and we're going to just start the session. So if you look in the screen on the right, you can see that we're in this box right here. So let me get into it. So we have our connection events, and that takes us to this function down here. So we have advanced frame, load game state, event disconnect from peer, and an event connected to peer. There's some other events here, but I'm not using them. So um, I'm not gonna leave them on because that creates a bunch of warnings, but I'm pretty sure for your game, you're gonna have to leave these connected, so make sure you look through those. So these connect everything here. These are connected. So let me go back to the code up here. You have game state, and basically that loads our game state, which is up here. And this has our update function, the save game state function, and the load game state function, and this checksum. Um, and this loads it here and it saves it to this variable up here. And then you pass in new player numbers. I might remove that because you don't really need it. So we'll see in the future. You have the local player handle, add player, that's right here, add player. We have create instance. And basically what this is it passes this whole game state object into GGPO. So it can call save game state, which is defined in here. So basically what GGPO will do is it will call this function from the C library. And I'll show you that once we get here. We have you set our frame delay to 2, like I said before, and then you add player. So you add player type remote, which is yourself, you add your handle, and you add your IP address and your player port. And actually, this is wrong. This should be our handle, actually. There we go. And then you add your opponent, which is add player, player type remote because he's connecting from another location, and then you put his handle, IP address, all that good stuff. Then you have register player, and basically what that does is it creates a player instance, and that's going to be a node that we're moving around. Here it is. It's basically just a kinematic body 2D attached to a sprite and a label. And the code in here basically just shows um, the player moving. Okay, so once you register your player, that player is going to pop on screen. Where is it? Yeah, your player is going to pop on screen. And then once your opponent connects down here, that opponent also gets registered. And then you pop on screen. And then now, since we're here, we're going to start the game. Okay, so let's get into add local input. So add local input is, first of all, it's connected to this huge game loop right here. And this game loop has everything we need to let GGPO work. And the way I apply this game loop in Godot is I use the physics process, which is up here. So everything that you see in this diagram happens in this physics process right here. So let me go through it. We start off with GGPO idle, and basically, since GGPO doesn't use Godot's networking features, it uses its own. So basically, you have to give GGPO a time to stop listening for packets and sending it so it doesn't bottleneck your code. And I did that right here. And this is the function I use to calculate it, which is not mine. It's the person who made GGPO. And you don't have to do all of this, but You can just put in GGPO idle and put in an integer, but since the guy who made it used this, I'm basically just going to follow in his footsteps and use that. So we define this variable called results, and if our local player handle is invalid, it would stop, but if it's valid, it goes into local input, and then you pass in the local input that you get from your keyboard, which is defined by this input variable right here, and it's basically calls read input, and that gets the input from your keyboard. Right is 1, left is 2, and then up 3, down 4, and if nothing is pressed, then 0 gets returned. So you put that into the add local input function, and then if everything goes well and your inputs gets added correctly, results should be good. And if that's good, you now go into synchronizing your input. So we come down here and then synchronizing input, you put in your max players. And if the synchronized input goes well, and synchronized input basically gets your opponent's input and your input, and then it combines it. So if that goes correct, you get results, it returns result, and results returns a dictionary, and um, it returns multiple stuff, but all you need to know is it returns your inputs and it returns if the result is okay. And I put on screen everything that it returns so you don't have to worry about that. And then you go into advanced frame, which is not, it's not, yeah, advanced frame. Yeah, I don't know what I'm talking about. Okay, so you go into advanced frame and you get your inputs. Okay, so advanced frame takes the inputs from the results that got returned by synchronized inputs, gets those inputs and passes it into the advanced frame function, which the advanced frame function calls the update function in gamestate. And if you remember from the diagrams that I made, um, the update function gets called by two functions. It gets called in the physics process loop, which is this loop right here, and then it gets called in the advanced frame function loop, and that's when GGPO needs to roll back a game state. So I'm going to go through and do the physics process loop first, and then I'm going to do the advanced frame rollback function. So let's get into that. So you got GS or game state calls update, and let me go into game state. Update is called here, gets the input, and you do for P in players. And if you didn't see before, players is this array at the top. And if you remember, in the register player in the main script, we made our instance, and at the end of the function, we add the instance into the array. So we have both player 1 and um, player 1 and player 2 scene instance stored into this array. So we go into the array and we loop through it. We call the move player function in each one of those instances. So let me go into that. So this would probably be player 1, and it's going to do player 2 move function. Both player 1 and player 2's move function is going to get called. So we get the input, and this should be self-explanatory. So if input 1 is called, it goes into here. Right is binded to number 1, left is 2, which matches up to these over here. And once that goes through, go back to player. If it's 1, you got velocity x gets increased by the walk speed. If it's left, which is 2, velocity x gets minus by the walk speed, and you go through. And if nothing is called, and this is what this underscore is right here, this is default, um, both velocity is equal to 0. And whichever velocity is changed, that gets passed into move and slide, which moves the object. But, and this is extremely important, it doesn't render the object on your screen yet. It just gets passed in, and I'm guessing what Godot does, and you can correct me in the comments, is it calculates where it's going to get moved to. So that's a big part you have to realize is that once you call move and slide, it doesn't render or it doesn't show it being updated on your screen immediately, but it is getting calculated. So move and slide, and then we get the position where it should be. So the move and slide gets the velocity and it moves your object, let's say to the right, and that's calculated. So your position changes since you're going to the right, and you have to round your value. And the reason why you have to round is because in GGPO, you cannot pass in um, a floating point number or a decimal number. I mean, you could go in and try changing it, but default code, you have to pass in an integer or a whole number. So we round up x and we round up y, and that gets passed into uh, here, where it doesn't get passed into anything, but it updates the player. Both players get updated, and we end this. So that's the update function right here. And the game is synced because advanced frame down here didn't get called. And we call this function right here, which is, since update is done going through, we call advanced frame, and GGPO knows to save the game state, which I'll go over later. And then you render the graphics. So once this, where is it? Oh, it's up here. So once you call this, that's the end of this physics loop. And then Godot knows to render the game because at the end of each physics process loop, um, Godot renders the graphics automatically. So yeah, you don't have to do it manually because it's Godot, it does it for you. So let's back up a little bit, and you see this goes in a loop again. We go back to the top, obviously. But let's go back here, and let's go into save game state. So once you call advanced frame, GGPO will go call save game state. And let's get into, I'm going to talk a little bit of the C# or the C++ code, and I'll try being quick because this might be a little bit complicated. So what happens is, and actually let me talk about saving the game state first. So there are a bunch of ways to save your game state into GGPO. And if you want to, let's say, get it the most optimized, you can, it's best for you to implement it yourself. And there's a bunch of ways you can implement it. My way is easier for you to edit your game state in Godot and change the way, the game state gets saved. Because remember, any edit you make in this module, you have to recompile, and any mistake, that's 7-minute slots compiling. So I didn't want to recompile every single game state I made or change I made. So I just decided I want to do all my work in Godot. So I made my game state able to save from the GD script editor in Godot. So it's much easier to change it around, but it might not be the fastest way. And um, the other way I figured out you could save Your game state is by making a structure and saving that game state to that structure by copying it to the structure in a loop and then putting that structure in the buffer. But you would have to change the structure, or anytime you change the structure, you would have to recompile it, and that will take a long time. So probably you can use that method when you are finished, I guess, or you are close to the end of your development and you figured out a way to save it. But it's ultimately up to you on how you save your game state. So I'll go through this a bit. So you get this game state right here, and this calls the save game state function in Godot. So it comes over here, and it calls this function right here, save game state. And if you're probably wondering how it knows how to save this specific script or how it calls this specific script is because at the beginning, remember, we created an instance and we passed it in. And that this instance or this game state got stored in the Godot module. And it's this property right here, save game state ref or reference. So this calls the game state, and what happens is um, I put in where is it? Okay, here we get for I in players. So you get each player, you get the velocity of that player, you get the velocity x, velocity y, you get the position x, position y, and you put a test string in. So I put string so you guys will be able to know that you can pass strings in and get them out once you load the game state eventually. So yeah, um, put eight. You can only put values up to 127, and that's because a signed byte has the range of 127 to negative 128. So, and the reason why I use put 8 is because I know the velocity um, would never go above 80 because of this limitation I put. Unless you're playing like Super Mario 64 and you are going backwards at the speed of light, I think you don't need to worry about you don't need to worry about limit going over the range. And if you do, you can easily change it. And you have this you come down here and you put the checksum, and you put the checksum in the 32 right here. And you might be wondering what in the world is a checksum. And what a checksum is it allows you to um, what a checksum is a checksum basically gets your data and gets your data array, does a bunch of calculations, and then it returns a number that's unique to that data. So when GGPO loads your game state, it knows which game state to load. And if you load the game state incorrectly, it will compare the old checksum to the new checksum. And if those two IDs don't match, then it stops and gives you an error. And I'll show you that happening once I run the sync test at the end. So that's what the checksum is. The checksum gets saved to the first value in an array, and then that gets passed into the save game state function. And let's go here. Gets called, and then that gets passed into here, and then a bunch of checks happens, and then that game state gets copied into the buffer, and the checksum gets copied into this checksum function, and then we can see that this buffer now gets the save game state. and it's ready to be called by loadgame state. So before we go into this, let's go back to this advanced frame. So let's go back here. So we know this advanced frame right here gets called by the physics process, but what about this advanced frame? So that one is down here, and this advanced frame gets called by GGPO. And you could honestly make this function and this function, you could combine it, but it'd be kind of troubling to figure out like one's getting called by Godot because at first glance you might think it's the same function, but I just separated them so it's easier to like tell like which one's getting called by GGPO. So you're probably wondering how this one gets called, and that's because we connected an, an event to that function, which is right here, and GGPO calls this function, then this function calls the update, and then you go through the advanced frame all over again. So let's run through it. Advanced frame calls update, you go up here. Update, is the game synced? Nope, because advanced frame is being called. So you go into the load game state, which is right here. Right here, GGPO calls this load game state, and load game state goes and looks into the buffer, and the buffer gets this game state right here. And you have to see the same way you put into the same way you save the game state, it's the same way you have to load it out. So just keep that in mind. And the functions, the get 8, 16, all have to be the same. So you go into the buffer and you load the game state. And once you load the game state, you come down here and then you synchronize input. And since you're probably wondering where you call this, and that's when you go into advanced frame right here. Oh, you go into synchronize input. Synchronize inputs then calls advanced frame. So basically you start this loop right here. And you're no longer using the inputs from this read input. You're now using the inputs from this synchronized input, which is the correct inputs and not the predicted inputs from GGPO. Yeah, and if you're wondering where the synchronized input is being called, if you go down here to Godot and you go to the advanced frame callback, which is right here, you can see synchronized input is getting the inputs from GGPO, and that's getting called here, and that's getting inputted to add inputs, gets converted to an array, and the array gets passed into advanced frame, which emits the signal, and that signal goes back to advanced frame here, and then you go into the update. And this update is called as many frames as needed until the rollback gets finished. And that's somewhere from your max rollback frames to your to one rollback frame. So you can have rollbacks as big as 15, or it could be as small as 1. So yeah, this function can get called really fast. And that's why it's important for you to optimize how fast your game state gets loaded in and loaded out. So yeah, this happens many times. Then it goes here. Once it's synced, um, it goes on to advanced frame, which is right here. And then it saves it, and then your frame gets rendered. And that's how it basically works. So I have to emphasize, once this happens, once this is getting called, or this function is getting called many times, since Since your physics process is not done yet because it's only on the update part, your graphics are not being rendered because all of these calculations are happening in the move or your player script. And the only one that's happening here is move and slide. So yeah, that's how you resimulate the physics is you have these functions called move and slide or move and collide or move your position. Those get calculated and then thrown back into the save game state when you need to. And then once that's finished and once your loop's done, it renders the graphics. Okay, so that's that. So let me run this through and let me see if I can help you with it. Okay, I said we're gonna do the sync test. Let's do it. So I turn this to true, and we're gonna start the sync test. And we're gonna roll back up 5 frames. And what we're gonna do is I'm gonna show you it getting rolled back. So let me make you some example code. Actually, no, I can just show you in the debugger. So I'll just show you it in the debugger. So I'll go through it. Um, Ideally, you want to use random inputs instead of just using for main. You want to pass in, maybe use a random function to mix up the inputs because um, you want to make sure that if you're even if your opponent's mashing or something, that it's all rolling back correctly. So that's probably a better way to do it than what I'm about to do. But I'm just gonna put the default to right, and the opponent should be able to go right. And I'm gonna pull this up real quick. Okay, so I was testing this later, so I do have some breakpoints. Oh no. Oh wait, I forgot to change this back after. See, this is what you have to do when you have to compile it. I made a change in this Godot Visual Studio editor, and since I did that, I now have to recompile this whole thing. So I'll be right back. So you're gonna see the checksums being checked, and let me show you. And we get rid of this breakpoint. Click go, and you can see checksum matches for frame 1, checksum, all the checksums matches for each frame. And you can see that the um, the object is moving really slowly, and that's because it's getting uh, it's getting each frame it's getting loaded in the past, and it's doing the physics calculations. And let me show you that real quick. So let me add some print statements for you can see what's really going on. Okay, I'm back. And for the load game state functions, I added some print statements to that. And you can see the buffer is now being printed. And in the save game state function, I did the same thing. And you can see the stream is now being printed. And I also went over here and added a print statement to advanced frame. And that would be able to demonstrate how many times advanced frame is being called per second. So I can show you why you need to be optimized in loading and saving your game state. And yeah, let me show you. So let me click play and we wait for this to load. Hopefully it does not crash. There we go.
and you can see this being called. So let me show you what's going on. So we're going to go back to the top, and you can see save GGPO save this game state, saves this game state, and since we're doing a rollback every frame, it goes back to this game state, loads that game state here. So right here, it's loaded, then it comes down to synchronize inputs, calls advanced frame, and advanced frame is called with this input, and that gets passed into update. And since update is correct with these correct inputs, it gets hit to advanced frame and then it saves the game, which is why this is saved. And then since this is running every frame, it loads it back again. So let me show you if we're gonna do um, more rollback inputs, because you're probably gonna be rolling back probably like 8 to 10 to 15 frames. So I'm gonna do about 7 frames of rollback. And we wait for it to load. Okay, it's loading. And yeah, you can see that it's doing much more work. So let's go through it. Go up here. So, or this is the wrong one. So you can see it gets saved 2, 3, 4, 5, 6, 7, about 7 times, and that's the 7 frames of delay that we put on. Well, not delay, but it runs 7 frames to be saved. Each frame gets saved, and then it gets rolled back by 7 frames. And you can see save, 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 saved, and then that saved is wrong, so it gets loaded here, and that's this loaded statement down here, and then it calls with advanced frame puts this input, which is the correct input, and then puts that into a save state, and then it goes back, and advanced input runs again, so we're down here in this loop over here, we're in this loop now over here, saved, checks if the save is correct. If the save is correct, we go to advanced frame, and then advanced frame passes in the input, so synchronized input to advanced frame, and the update, and it keeps going through here with the correct inputs, not the predicted ones, and then we're good. And then see all of this, I believe, happens in one frame. And once this is done, you go back to regularly saving. And it does it all over again. So that's why it's super laggy when you watch or when you look. It's every frame is rolling back the certain amount of frames you put. And it's really good for testing. Highly recommend it. Okay, so now that we're done with sync test, I'm gonna show you how to connect to other players, which is actually extremely easy. And I'm gonna wrap up this tutorial because this has gone long enough. So let me bring up the other project. Okay, so we got our 2 projects here, and let make sure to turn off the sync test. So make this false. And I'm also gonna go to this game state and takes this off because we don't want this. I want you to see the player handle, and I'm gonna do the same thing for this one over here. Go to sync test, change out the false because we want to start an actual session. And then I want you to see the see the player, so gamestate GD. I'm here, edit that out. That should be good. And then if you want to run two projects at the same time, you have to go to this and then change the remote port because you can't run two projects at the same time unless the remote port is changed. So we're gonna go here, we're gonna click play for this, click play for that, and we'll wait for the projects to load. Oh, actually, before we load this one project, almost forgot. We have to go back to main, and since these are the exact same copies, we have to change our player handle to 2, and our opponent's player handle is 1, and then we're going to change our opponent's port is 70, and our port is 7001. So let's do that. So we got player 1 here, and then I'm going to load in player 2. Make this a bit smaller, and wait for this one to load. I'm going to take this off the screen again. You see. Okay, so we have both programs or projects up and running, and you can see that they connect to each other because if you look in the Godot console, you can see that the inputs are getting saved and the game states are getting saved every frame. And if we go into the other one, you can see that it's also printing out the inputs. So if I remove on both of these, you can see the inputs being printed on the console. And if I do this, well, you won't be able to see it, but you'll be able to see the inputs being changed. You can see the save states being modified. But that's not what I want to show you. Right now, I want to show you this program here called Clumsy. And what Clumsy does, it basically allows you to lag test your game and stress test it so you can see how your game would perform in certain scenarios. Because the internet, as much as I hate it, we're not going to have a lagless connection every single time. It's probably going to be laggy, and the way that packets get transferred on the internet is different. So you want to see if your program works correctly under those situations. So Clumsy gives us a bunch of options that you can use. You can lag your connection by a set amount. You can drop packets. You can throttle packets. You can duplicate packets. You can send packets out of order, and you can tamper the packets. So these are all real-world situations, and you can see how your program can perform under them. Right now, we're just gonna use the lag, and we're gonna do 50 millisecond delay, and we're gonna start it. So as you see, and let me move this over here, you can see that Godot it basically performs as well as it should. It might be lagging a little bit because the print statements, but if you compile this as a full exe, it should be as fast. You can see basically runs pretty well. You can see the top frame. I'm controlling this one, and you can see this one is teleporting around a little bit, but you can see it instantly snaps back. So let's up the delay by another 50 to 100. So let's stop this, bring it to 100, and click start. You can see how the rollback is much more, and the player is snapping to more places. You can see once I go and once I stop moving, it goes and then it snaps back. See? So you can see it snaps back into place, and that's it getting loaded back. But that's good. And let's bring it to 150. And I think 150 is kind of like the max where if you have 150 delay or millisecond delay, it starts to get iffy. But we want to stress this as much as possible. And you can see the lag is getting much bigger, way bigger delay, And if you're on like 150 milli per second, you probably need to change your frame delay to, or your delay base project or delay base function to free free frames of delay, which is this thing right here. If you don't know what I'm talking about, you probably need to change this to free, so don't forget about that. And we're gonna do it to 200. Stop and start this, and you can see it's really bouncing around. And if you click here, it'll do the same thing to mine. But you can see that I always have basically full control over my character, but it will lag a lot on this type of connection. But that's obvious that you can be lagging at 200 milliseconds. So that's basically the project. Um, if you have any questions, you can always come to my Discord. Link is down below. I'm not the best at GGPO, but I can at least try and help. And if you have like questions about like the Godot engine or like how to compile a module, once again, you can go refer to um the first tutorial that I did, or you can go into the Godot Discord and ask. And then yeah. Oh yeah, one more thing. Also, if you go back here, if you want to check like your ping or the network connection, and I'll show you it real quick. All you have to do is go to this, and there's a lot of other functions that you can use, but you just have to type in where is it? No, it's not a signal. Get network stats, and then network stats will return a dictionary, and it would have the ping, the frames, and all that stuff. So I'm going to go into the physics process, and you don't really want to be printing that much from the physics process. Let me go here. I'm trying to go as fast as possible, so because I know this tutorial is going to be pretty long. I'm just going to do print. I'm not sure why this is so little, dude. Okay, there we go. So make sure you put your opponent's player handle in the GGPO network stat instead of yours, and you can see the information getting sent and received. Ping is at holy crap. But that would make sense because we need to stop this, and when we click stop, um, this should go down, and you can see the ping goes instantly down to should be around really low. Ping at 1, yes, because it's on our local machine. But yeah, that's it. So if you have any questions, once again, go into Discord, and I'm gonna thank you for watching to this far. So I'll see you later. My voice is absolutely gone, and peace out.